Today we are going to be writing algebraic expressions. And so the first thing we're going to look at is some different words to represent operations. So we talked about order of operation way back in section 3 of chapter 1, and these are the different operations we have. We have add, subtract, multiply, and divide. We also had exponents and parentheses involved in order of operation, but these are our operators. And so what does it mean to add? Well, adding means when we want to bring things all together. So typically when you see the words all together, that tells us that we're going to end up adding. And so some words that they use for adding, of course, are plus, that we see oftentimes, but we also see more or greater. So these are words that often tell us that we're going to end up dealing with adding. So when they say more than, greater than, then we know we're dealing with adding. Subtract. Subtraction is when we want to compare numbers. So whenever we compare, we want to subtract. So oftentimes when we are comparing, we're going to, for instance, if we have a high temperature of 70 degrees and a low temperature of 50 degrees, we want to compare those two numbers, so we'll subtract them to find out what the difference is. And that's a word that we're going to use for subtraction is difference. And so we also have some other phrases that they might use, like less or fewer than. So those are different words that they use to represent subtraction. Multiply. Multiply is one of those that goes along with addition. It's when we're combining things together. So this is groups of the same numbers being added together is what this represents. So groups of the same number being added. And that's why we ended up coming up with multiplication, is because there was a faster way to add the same number over and over again. We could end up multiplying it. And so a word that you're going to look for is product. When you see the word product, that means that we're going to end up multiplying. Division. Divide goes along with subtraction. It's the reciprocal of multiplying, and it's another way to compare numbers. So when we want to compare, like finding out what the not the difference, but the quotient of something is, or the ratio of something, we want to compare two numbers with a percentage, that's when we're going to end up dividing. And so that's the word we're going to end up using. I mentioned before, it's quotient. And so when we see that word quotient, that tells us that we are going to set up a division problem. One more that goes with add that I want to add in here is sum. Sum just means that you're going to add numbers together. So let's go ahead and use some of these words in these algebraic expressions that they have here. And we're going to write in algebraic expressions from these word phrases. So 4 times the sum of a number and 608. When they use the word sum, they're talking about adding. So we're going to end up adding these two numbers right here. So we know we want to add those. But because they said 4 times the sum, we need to make sure we add first. So we add first. Now, how do we make sure that we add first? Well, that's where parentheses come into play. So we're going to take the 4, and we're going to multiply it second. Well, in order to multiply it second, that means that I need to add first, and that means that I need to put parentheses around the addition. So I'm going to add the n and the 6008 together, and then multiply. And that's the phrase, that's the algebraic expression that I would write. Here it says 3 times the difference. So difference means we're going to end up subtracting. So we're going to subtract, but because we are going to subtract and then multiply, difference here is telling us that we want to subtract first. And so here it says difference of a number squared and 82. So I want to make sure I subtract that first. So I got n squared, that's the number squared, is n squared, and 82. So I'm going to subtract 82 from that, n squared. But since I want to subtract first, before I multiply by this 3, I need to put parentheses around that difference. So 3 times the difference means that I'm going to end up subtracting first. Here it says the quotient of 100 and w. So this is just a division problem. So quotient means to divide, and to show this, we're going to write this as a fraction. So this is the way I want you to write it, 100 over W. It means the same thing if you wrote it as 100 divided by W, but we're getting away from this way of writing things because we're more moving towards an algebraic expression. And typically in algebraic expressions, we don't use this sort of division sign. We use this sign here. So this is the way we're going to end up writing it. 100 divided by W. So whatever comes first is what goes on top. Second goes on the bottom when they're dealing with quotients, when they use that word quotients. 200 less than half a number. So 200 less than, that means that we're taking 200 away from half the number. And so we've got to take half the number first. This has to go first because we're going to take away that 200. We're taking 200 less than that number. So 1/2 the number, we don't know what the number is, so we're using a variable to represent it, and then take away the 200 is the way we'd end up writing that. So 1/2 n minus 200. We have the same situation here. 12 less than 15 times x. So we've got to start here. So this is what goes first. It goes first because we are doing 12 less than this. So 15x and then minus 12. So whenever you see 12 less than, or if it said 12 more than, we would be adding 12 to it. So those words less than typically tell us that that is going to go last in that expression. Here we have twice the sum. So remember, sum means that we want to add something first. So twice means 2 times. So 2 times, and then we'll put parentheses because I want to make sure I do the sum. This stuff needs to go first. And so we need to make sure we do that operation first, then take twice the number. Otherwise, we wouldn't be adding first, we'd be multiplying. So we do the sum of a number and 600, and then we twice that number, then we double that number. So here we're supposed to write some word phrases to match this algebraic expression here. So a few different ways you can write it, but let's get in the habit of using this phrase less than when we're talking about subtraction. So we would say 54 and W. See how it's in that fraction form? That's when we use the word quotient. So we'll say 54, the quotient of 54 and W less than 100. So the quotient of 54 and W less than 100. So we've got to take this quotient here, and we're taking it away from 100 is what that's representing. On this next one, we have another division problem, so we're going to use the word quotient again. And so we would say the quotient of 45 and the and means now we're dealing with the fraction bar, and the product. And I say product because these things are being multiplied. Notice that there's no sign between the 5 and the s squared, so we're now multiplying. So, and the product of 5 and a number squared. So that's the expression we have here. So 40, the quotient of 45 and the product of 5 and a number squared. So once you see the word and, that represents the fraction bar, and then we represent the denominator with that product of 5 and a number squared. Well, our other problems here are some word problems, but we're just going to write algebraic expressions to represent them. So it says an albatross can sleep while flying. That's pretty amazing. Can sleep while flying 25 miles an hour. An albatross flew 3 miles awake and another n hours asleep at 25 miles an hour. We're supposed to write an algebraic expression to find the distance it flew, or it had flown. Anyhow, what we're going to end up doing is distance represents miles in this case, not miles per hour, but miles. So we've got 3 miles. It flew 3 miles awake, And so then we're going to add on. And typically when you see that word and, that's going to tell us that we're adding something. And so 3 and n hours at 25 miles per hour. So a distance equals rate times by time. And so that's what we have here is a rate, miles per hour, times by time, n hours. And so we do 25n, and that would be the expression that we'd use. Next one here says Ed is a gardener, and it takes Ed 35 minutes to plant a bush, 55 minutes to plant a tree. Write an algebraic expression to find out how long, so they're talking about time now, how long it takes to plant B bushes and T trees. We don't know how many bushes he's going to plant, but it takes him 35 minutes to plant a bush. So we would say 35B. Now, and tells us that we're going to end up adding something together, so we'll put plus there. So plus, and then T trees. Well, it takes 55 minutes to plant a tree. So 55T, and that would be our expression. Well, looking at another problem, it talks about you have D dimes, Q quarters, and nickels. Write an algebraic expression to find the total amount of money. And so total means that we're going to end up adding. This is another word for adding. It's the same thing as sum. And so we don't know how many dimes, and it says the total amount of money. So amount means dollars. So that means we need to know how much money, or it could also be cents too. So we could use cents as well. Why would you go with cents? So how much, the amount of money we're going to have here? Well, we have to multiply the number of dimes by the amount one dime represents. It represents 10 cents. And then we have to write the number of quarters, Q, but how much is a quarter worth? 25 cents. And then we have the number of nickels. But how much is a nickel worth? 5 cents. See, this would give us the amount of money. So the total amount means that we had to, total meant add, but because it said amount of money, we needed to multiply it by the value of the coins. So that's why I multiplied by those numbers. Walking burns 275 calories per hour. Jogging burns 500 calories per hour. Write an algebraic expression to find the calories burned from S hours walking, T hours jogging. S walking, well, here it is. Walking is 275 calories per hour. Per hour means that every hour we're going to burn that many. So we have 275 calories times the number of hours we're going to walk. That's the number of calories we'll burn. Plus, because it says and tells us that we're going to add, T hours jogging. Well, we burn 500 calories per hour. Well, if we multiply that number by the number of hours that we are jogging, that will give us the total number of calories burned. And so that would be our expression. So you have to be really careful on tonight's homework looking for what they're asking for. Remember, amounts of money would be, you'd have to multiply by the amount of money that we had for each of the coins. The number of calories per hour, well, multiply by that rate by the time. That gives us what the number of calories are in this case. Those are the problems that you're going to see on tonight's homework. Good luck.